Now let's look at assembly drawings, and this one will be pretty short. An assembly drawing is different from a detail drawing. An assembly drawing just takes parts that may be already manufactured someplace else, like let's say the blade to this screwdriver and the handle to this screwdriver. And it shows here's how you bring them together in an assembly. It lists item numbers, so here are item number bubbles, 1, 2, 3. It lists those in the bill of materials, so here they are below, 1, 2, 3. And then it gives any information that your assembler might need. It does not give any or many dimensions because usually these parts are already made. They're done. Somebody gets them out of a bin or a pallet and is going to put them together. So think about what will your assembler need, if any. In this drawing, the assembler needs to know about putting epoxy in there and drilling the handle. They don't need to know what size this screwdriver blade is, because that was made earlier. Something else I was going to say about that, but I've forgotten what it is. The item number bubble has to be big enough to hold an 1/8 inch piece of text. So make a circle that is somewhere between 3/8 diameter and 1/2 inch diameter. You can decide what size you like. This is an example from an ASME standard. This is the ASME standard about different types of drawings. So here's their assembly drawing. And notice a few points here. They have 3 item numbers, 3 item number bubbles. They do not have a bill of material. Instead, they have a note that says see separate parts list. So this is one of those. Then they have some square symbols. And those relate to this list of notes up here in the upper corner. Oftentimes notes will be down in the lower left corner where there's a piece of real estate available, but in this drawing they've put them up here. So for note number 1, you look up here and find out what it is you're supposed to do as the assembler with note number 1, and so on and so forth. So they use geometric shapes to communicate whether this is an item number or some kind of note. Some companies use triangles or hexagons, by the way. And I should point out that this example does not have these bubbles lined up. And just kind of notice how that makes it harder to stare at this drawing and interpret it. You have to sort through, okay, what have I got here? What are these pieces of information? If the drafter would have taken a little time to line up all those bubbles, it would have been a lot easier to read. Now this one is a totally excessive example. I think this is out of our book. This is kind of overkill. But the point remains, when you make your bubbles lined up in a line, they are much easier for the reader to read, and they make you look like a professional. If you have bubbles all over the place, it kind of looks a little, I don't know, casual. Having them lined up is a quick way to get your drawing to look professional. And the reader might not know why this looks like a really good drawing. They just notice, yeah, this looks pretty pulled together. Now, here's an assembly drawing with some bubbles are lined up. I lined up some in this row down here, but I didn't line up some of the others. And so it's just kind of a jumble. And there are enough parts on this machine anyway. Having those bubbles go up and down doesn't really help. By the way, this particular company had some parts, like you can see this one here, had a 4-digit item number. Here's another one. So they had to use these oblong bubbles instead of circles. All right, so there's bubbles kind of jumbly. Here's a drawing that also has a lot of parts, but I did bother to line up the bubbles, and most of them. There are a few of them that are not. And you notice how it just kind of cleans the thing up. It just makes it easier and faster to read. And it makes you look a little bit more like you know what you're doing. And then this is a repeat idea again, but I just want to remind us that when we're making an assembly drawing, each of the items in our assembly has an item number bubble pointing to it, and that matches item number 1 in the bill of material. Now, if you have 3 welded T's in your handrail, you only need to point to one of them with a bubble. And this bubble follows the rules of leader lines. And in fact, as usual, I do things the stupid way instead of the modern fast way, because I don't know how to do the modern fast way. So when I do a drawing, I make an actual leader, and then I come along and I draw a 1/2 inch or 3/8 circle in a piece of text and I stick it onto the leader. That's probably not the efficient way to do it. I'm pretty sure that AutoCAD has an automatic bubbly thing in its leader panel. I just don't know how to use it. Maybe if you know how to use that, please share it with us and we'll pass it along. And so anyhow, this is a leader and it needs to follow the rules that a leader has. It needs a short landing here, about 1/4 inch. It needs an arrow at the end that is the same length as the text is high. And this leg with the arrow needs to be within 15 degrees of horizontal or vertical. In other words, as some people say, between 15 and 75 degrees. So there is a quick tour of an assembly.